Somewhere above you right now, there may be an aircraft you cannot see. You cannot hear it. You cannot track it with the naked eye. It's flying at 50,000 feet. It has been watching the same target for 14 hours without stopping. Its cameras can read a license plate from 5 miles away. Its sensors can detect the heat signature of a human body through the roof of a building. And the pilot controlling every move it makes is sitting in an air-conditioned trailer in Nevada drinking coffee. What is the MQ-9 Reaper? The MQ-9 Reaper is a remotely piloted aircraft, a drone designed and built by General Atomics Aeronautical Systems for the United States Air Force. It entered operational service in 2007, and in the nearly 2 decades since, it has become the most combat-proven unmanned aircraft in history. It has a wingspan of 66 feet, comparable to a small regional passenger aircraft. It weighs approximately 49 pounds empty and can carry up to 38 pounds of sensors, weapons, and fuel. It is powered by a single Honeywell TP-300 and 31 turboprop engine that gives it a maximum speed of 300 miles per hour and a service ceiling of 50,000 feet, well above the range of most portable surface-to-air missile systems. But what defines the Reaper is not its size or its speed. It is its endurance. A single MQ-9 can remain airborne for up to 27 hours on a single mission. It can loiter, circling silently above a target area, for an entire day before returning to base. No human pilot can do this. No human pilot can sustain the focus required to monitor a single location for 14, 16, 20 consecutive hours. The Reaper can, and that endurance is the foundation of its value as a military asset. The MQ in its designation stands for Multi-Role Quotient, a designation reflecting its dual capability as both a surveillance platform and a weapons delivery system. The 9 places it in the Predator series, an evolution of the earlier MQ-1 Predator that proved the concept of armed drone warfare in the skies above Bosnia and Iraq in the late 1990s. The surveillance technology. The MQ-9's primary sensor system is the DA-1 multispectral targeting system, a gyroscopically stabilized sensor turret mounted beneath the nose of the aircraft. This single device contains multiple sensors operating simultaneously: a color television camera, an infrared camera sensitive to temperature differences of less than 1 degree Celsius, a laser rangefinder, and a laser designator capable of illuminating targets for precision-guided munitions. The infrared sensor is the capability that most changes the nature of surveillance. Heat cannot be hidden. A human body radiates a distinct thermal signature regardless of camouflage, regardless of darkness, and as stated in the hook, regardless of a roof or thin walls. The Reaper's infrared sensor can detect a person moving at night, identify whether they are carrying a weapon, and track their movement continuously for hours without ever losing them in the crowd. The camera resolution of the targeting system is classified in its full specification, but open-source analysis and operational accounts confirm that the Reaper can identify individual faces and read vehicle license plates from altitudes above 10,000 feet, altitudes at which the aircraft itself is invisible and inaudible to anyone on the ground. This is not zoom capability in the photographic sense. It is optical engineering of extraordinary precision, stabilized against the vibration and movement of the aircraft by a gyroscopic mount that keeps the image rock-steady regardless of turbulence. In addition to the primary targeting system, the MQ-9 can carry the Lynx multi-mode radar, a synthetic aperture radar system that can map terrain and detect moving targets through clouds, smoke, and complete darkness. It can also carry the ZP Iminus 1-star light radar, the wide-area airborne surveillance system capable of monitoring areas spanning several city blocks simultaneously, and signals intelligence packages that intercept communications from adversary radios and mobile phones. The combined sensor suite of a fully equipped MQ-9 is, in effect, a flying intelligence collection platform of a sophistication that would have been considered impossible a generation ago. Multiple sensors feeding data simultaneously, that makes the aircraft effectively invisible, and a satellite communications link that transmits everything it sees in real time to analysts and commanders who may be on the other side of the planet. How it is controlled. The MQ-9 Reaper is operated through two distinct communications links, and understanding both is essential to understanding what makes it work and what makes it vulnerable. For takeoff and landing, the Reaper is controlled by a crew at the airfield where it is based, often a forward operating location in the theater of operations. This crew uses a line-of-sight radio link to manage the aircraft through the most critical phases of flight, when precise control inputs are most necessary and communication delays most dangerous. Once airborne and beyond line-of-sight range, control transfers to a ground control station located anywhere on Earth with a satellite uplink. The aircraft and its controllers communicate via commercial and military satellite, primarily through the Ku band and UHF frequency satellite links, with the signal traveling from the drone up to a satellite in geostationary orbit 22,000 miles above the Earth, back down to the ground control station, processed, and the pilot's control input returned to the aircraft via the same path. This entire round trip, signal from aircraft to satellite to Nevada and back, introduces a communication delay of approximately 1.2 seconds. For most surveillance and strike operations, this delay is manageable. The Reaper's flight management computers handle routine stability and navigation automatically, requiring the pilot to make only higher-level control inputs. But the delay is real, and it is one of the reasons the Reaper operates differently from a manned aircraft, requiring more anticipatory flying and continuous coordination between the pilot and a sensor operator who manages the camera and targeting systems simultaneously. A standard Reaper crew consists of two people: the pilot, who controls the aircraft's flight path and weapons, and the sensor operator, who controls the camera systems, tracks targets, and manages the intelligence collection suite. Both sit in the same ground control station, a trailer-sized module filled with screens and secure communications equipment. They may be controlling an aircraft flying above Afghanistan or Syria while physically located at Creech Air Force Base in the Nevada desert, never leaving the continental United States. The weapons of precision that defines a generation. The MQ-9 Reaper carries weapons on 4 underwing hardpoints and 2 additional centerline stations, a total payload capacity of 3,750 pounds. Its standard armament includes the AGM-114 Hellfire missile, the GB-12 Paveway II laser-guided bomb, the GB-38 Joint Direct Attack munition, and the AIM-9 Sidewinder air-to-air missile. But the weapon that has most defined the Reaper's role and generated the most debate about the ethics of drone warfare is the AGM-114 Hellfire. Originally designed as an anti-tank missile for attack helicopters, the Hellfire has been adapted for the precise elimination of individual human targets. It weighs approximately 100 pounds, travels at nearly Mach 1.3, and has a warhead designed to penetrate armor. But in the drone warfare context, what matters most about the Hellfire is its accuracy. The Hellfire variants used by the Reaper are laser-guided, meaning the Reaper's sensor operator illuminates the target with a laser designator, and the missile homes in on the laser spot reflected from the target's surface. The circular error probable, the radius within which the missile will land 50% of the time, is measured in meters. The R9X variant of the Hellfire, sometimes called the Flying Jinsu, forgoes an explosive warhead entirely, deploying 6 blades on impact to kill with kinetic force rather than blast, minimizing collateral damage to people within feet of the target. The precision of these weapons is not incidental. It is the central military argument for drone warfare. A manned aircraft delivering a 500-pound bomb destroys everything within a significant blast radius. A Reaper delivering a Hellfire can eliminate a single individual in a vehicle, in a building, or on a street, with damage confined to the immediate target area. United States Air Force data indicates that MQ-9 strikes achieve a circular error probable of under 2 meters in optimal conditions. The weapon goes where the laser points. The laser goes where the sensor operator directs it. The sensor operator can watch the target for hours before making that decision. This precision, however, is not absolute. The accuracy of the laser guidance depends on the quality of the intelligence that identified the target. Where it was aimed is only as precise as the decision about what to aim at. This distinction between technical precision and intelligence accuracy is at the heart of every serious debate about the consequences of drone warfare. A typical MQ-9 combat mission begins not in the air, but in an intelligence fusion cell, a room where analysts from multiple agencies combine signals intelligence, human intelligence, imagery intelligence, and pattern-of-life analysis to build a target package. Before a Reaper is ever tasked against a target, that target has typically been studied for weeks or months. Movement patterns, associates, communications, vehicles, locations. The intelligence picture is assembled with painstaking care. Once a target package is approved through the military's legal review process, a process involving judge advocates, intelligence officers, and command authority, a Reaper is assigned the mission. The aircraft launches from its forward operating base, climbs to altitude, and begins what is called a persistent stare over the target area. The sensor operator begins recording everything the cameras see. What follows may be hours of observation. The Reaper watches. It records. The sensor operator tracks movements, identifies individuals, confirms the presence of the designated target, and assesses the surroundings for civilians or other non-combatants. The pilot maintains the aircraft in a precise orbit that keeps the target continuously in the sensor's field of view. Ground commanders and intelligence analysts watch the same feed from their own screens, often thousands of miles away. When conditions for a strike are determined to be met, the target confirmed, the surroundings assessed, the legal authorization in place, the sensor operator illuminates the target with the laser designator. The pilot releases the weapon. From weapon release to impact is typically between 8 and 15 seconds for a Hellfire fired from operational altitude. In those seconds, the sensor operator watches the laser dot. The pilot watches the aircraft systems. And somewhere below, a person who does not yet know they are about to die continues their last movements. After the strike, the Reaper remains on station. The sensor operator documents the effects. Battle damage assessment, confirming whether the objective was achieved, whether there were unintended casualties, whether secondary targets were present, is conducted from the same camera feed that guided the strike. Everything is recorded. The footage becomes part of the operational record of the MQ-9 Reaper reads like a history of American counterterrorism operations over the past 2 decades. It has been the primary strike platform in the targeted killing program that has eliminated senior leaders of Al-Qaeda, ISIS, Al-Shabaab, and affiliated organizations across multiple countries and continents. In January 2020, an MQ-9 Reaper fired the missiles that killed General Qasem Soleimani, commander of Iran's Islamic Revolutionary Guard Corps Quds Force, near Baghdad International Airport. The strike was ordered by President Trump and executed with the precision the Reaper was designed for, a single vehicle targeted among multiple vehicles near an airport, the strike killing its occupants while leaving surrounding infrastructure intact. It was, by any technical assessment, a demonstration of exactly what the system was built to do. In August 2022, a different precision strike, this one attributed to an over-the-horizon capability operating on similar principles, killed Ayman Al-Zawahiri, the leader of Al-Qaeda, on the balcony of a safe house in Kabul. The strike used the R-9X Hellfire variant, the bladed missile, killing Al-Zawahiri without damaging the structure of the building or harming others inside it. The precision was, by any historical standard, extraordinary. In Operation Rough Rider, the campaign of over 1,100 strikes against Houthi targets in Yemen conducted between March and May 2025. MQ-9 Reapers operated alongside manned aircraft and naval vessels to provide continuous surveillance and precision strike capability against targets that included radar systems, missile launchers, drone production facilities, and command infrastructure. The Reaper's endurance, persistent coverage of target areas through an entire operational cycle, from target identification through strike execution and battle damage assessment. The future, what comes after the Reaper? The MQ-9 Reaper is already being succeeded. The United States Air Force has begun the transition to the MQ-9 billion Sky Guardian, an upgraded variant with extended range, improved sensors, a de-icing system that allows operation in all weather conditions, and a satellite communications architecture updated for the contested electromagnetic environments of near-peer competition. The Sky Guardian has been purchased by the United Kingdom, Belgium, Italy, Australia, and other allied nations, extending the Reaper family into a genuinely global coalition capability. Beyond the Reaper family, the next generation of American unmanned combat aircraft is moving in a fundamentally different direction. The MQ-28 Ghost Bat, the XQ-58 Valkyrie, and the emerging collaborative combat aircraft program envision not a single large surveillance and strike platform, but fleets of smaller, faster, more expendable autonomous wingmen, aircraft that operate alongside manned fighters, absorbing risk, extending sensor reach, and delivering weapons under the supervision of a human pilot who may be controlling multiple unmanned aircraft simultaneously. The MQ-9 Reaper emerged from a specific strategic context: counterterrorism operations against non-state actors in permissive airspace, where no adversary could shoot it down. The future of drone warfare is being designed for a different context entirely. Contested airspace, near-peer adversaries with sophisticated air defenses, electronic warfare capabilities designed to blind and disrupt drone communications links, and anti-satellite systems that could cut the very satellite links the Reaper depends on. The drone that hunts from the sky is evolving. The platforms are getting faster, smaller, more autonomous, and more numerous. The legal and ethical frameworks governing their use are still catching up. And the fundamental question that the MQ-9 Reaper first posed: what does it mean to conduct war at a distance, with precision, without risk to the operator? Evolved as it was the day the first Reaper took flight. This was the MQ-9 Reaper, the machine that changed the meaning of the word precision, and the weapon that made war invisible to everyone except the people on the receiving end.